Hello everyone. The topic that we are going to discuss today is Introduction to Number Systems from the first chapter, Number System. Maths is all about numbers. Everything that you learn in mathematics is nothing but different form of numbers pattern, actually not just maths, but all the physical phenomena, natural phenomena, everything can really be explained using number patterns. So these number patterns are the very core of all maths or all natures. Let us look at a very simple number pattern, a counting number. Let's say 1, 2, 3, 4, 5, and so on. What are these sets of numbers called? This sets of numbers is called natural number. It is normally represented by n. We can count everything, for example. Now there are 3 apples inside a basket, so the number of apples can be represented by a natural number. Now, if we remove all the apples from the basket, how will you represent the number of apples left in the basket now? You can't. We know bring in a 0. So if we include 0 to the set of natural number, we now get whole number. It is represented by W. Now, what happens if we subtract 4 from 2, that is 2 minus 4 equal to minus 2. Now, minus 2 is not a whole number. To be able to represent minus 2, we add another set of number to the left of 0. These are nothing but negative of natural numbers. This entire set of number is called integer. It is denoted by I. Do we now have all the numbers possible? Seems like a lot, but not really. Let's zoom into a section 0 to 1 of a number line to see. Between 0 and 1, we have 1 by 2, that is half. And between 0 and 1 by 2, we have 1 by 4, and so on. We will get infinite set of number. These are not integers. They are called rational numbers. Let us see from the definition of rational numbers now. The numbers which can express in the form of p by q, where p and q are co-prime integers and q not equal to 0. It is denoted by q. Example of rational numbers: 0, 1, minus 3, 1 by 4, minus 1 by 2, etc. All these numbers are in the form of p by q. For example, say 0. 0 is nothing but 0 by 1. 1 also is written as 1 by 1. Minus 3 can be also written as minus 3 by 1. They are in the form of p by q, where the denominator, that is q, not equal to 0. What is coprime? Let us try to understand first. Two integers are said to be coprime if the HCF is 1. Example 4 and 5, 6 and 7, etc. Here, the HCF of 4 and 5 is 1 because there is no common factor other than 1. So these two numbers are said to be coprime integers. So, from the definition of rational numbers, 5 by 10 is not a rational number, but it is the equivalent of a rational number 1 by 2. Since there is a common factor 5 between 5 and 10. So we can write 5 by 10 equal to 1 by 2. So 1 by 2 is a rational number and 5 by 10 is the equivalent of 1 by 2. So we can say that all natural numbers are whole numbers, all whole numbers are integers, and all integers are rational numbers. However, the reverse is not true. Now let us see another set of numbers called irrational numbers. Until one of the Pythagoreans wondered, how do we represent square roots of 2? There is root 2. He was interested in root 2. He looked at his number line and realized that it cannot represent this because there are no two numbers p and q such that root 2 equal to p by q, where p and q are coprime integers and q not equal to 0. The same was true for the constant pi, where pi is equal to circumference of a circle divided by the diameter of that circle. For calculation, we use the approximate value of pi as 22 by 7 or 3.14. This is for convenience. Actually, these are not the real values. The value of pi in decimal form is equal to 3.1459263 and so on. So it cannot be expressed in the form of p by q, where p and q are coprime integers and q not equal to 0. So let us see the definition of irrational numbers now. This number, which cannot be expressed or represented in the form of p by q, where p and q are coprime integers and q not equal to 0, are called irrational numbers. Examples: root 2, root 3, root 5, root 6, and pi are some of the examples of irrational numbers. Let us see what is real numbers now. We should also remember that rational numbers and irrational numbers are two separate sets of numbers. The number which is rational number cannot be irrational numbers. The number which is irrational numbers cannot be a rational numbers. In a very simple way, we can say that irrational and rational numbers are two different sets of numbers. Now, if we combine the set of rational numbers and the set of irrational number, we have a real number. So, together form a set of numbers called real numbers. Let us see some of the examples. The first question: Is 0 a rational number? Can you write it in the form of P by Q, where P and Q are co-prime integers and Q not equal to 0? Yes, 0 is a rational number because it can be expressed in the form of P by Q, where P and Q are co-prime integers and Q not equal to 0. For example, 0 can be expressed as 0 by 1 or 0 by 2, etc. Let us see the second question. Find 5 rational numbers between 3 and 4. Between 3 and 4, we can have infinite numbers of rational numbers. And the question asks us to find out only 5 rational numbers. So we can have in decimal form as 3.1, 3.2, 3.3, 3.4, 3.5, which are equal to 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10. When we reduce in the simplest form, we have 31 by 10, 16 by 5, 33 by 10, 17 by 5, 7 by 2. These are the 5 rational numbers between 3 and 5. You can also have different rational numbers between 3 and 5 because there are infinite number of rational numbers. For your homework, I'm giving a question. State whether the following statements are true or false. Give reason for your answer. If your answer is false, you can give an example. But if your answer is true, you should give reason in a generalized form. The first question is, every natural number is a whole number. And the second question is, every integer is a whole number. The third question is, every rational number is a whole number. I hope you understand what is rational numbers, what is irrational numbers, and the difference between the irrational numbers and rational numbers. Thank you very much.